All right, now for your third kinematics equation, okay? We've done the first equation, which is V equals AT plus V naught. We've done delta X equals, no, I don't want that form. Same thing, X equals X naught plus V naught T plus 1/2 AT squared, all right? And you realize that the slope, this line here, is this equation. X versus T squared is this equation. And this slope, you know, is A, is your acceleration. This slope is actually 1/2 of A. So 1/2 of your acceleration, right? So let's go to equation 3. All right? Now, it's essentially figured out the same way. Take a velocity time graph. All of these equations come from your velocity time graph, in case you haven't realized. So centimeters per second, time, seconds, right? Now, what if we find the area under this graph again, right? Except now, you know, I'm just going to call this V and T, all right? I'll label things. Let me move this down a little bit, make it look a little cuter. V naught, call that V final, call that T, and let me move my 3 over, all right? Velocity, and this axis is time, right? Now, instead of finding the area of the rectangle and adding it to the triangle, this is a much better way. Isn't this shape something you know how to take the area of? Isn't that a trapezoid? I think it is. And wow, that was good. So I'm going to group these. I want to show you something really quick. And I'll clone it. And then I'm just going to rotate it sideways, because for a lot of people, that makes it easier to see, okay? These are the same thing, okay? You can go back and forth between the two. So if we find that red area, hopefully you're realizing that that red area is displacement. And if I want the area of a trapezoid, it's going to be the average of the bases times the time, right? It totally makes sense, because a rectangle is simply base times height. Well, we have 2 dimensions here. We just average them. So really what we're doing is we're finding this area, which is identical to the area of that trapezoid. Okay? So let's do it. Except instead of the average of the bases, you know, this base is our final velocity, right? This base is our initial velocity. And our height is t. So the area of this trapezoid is just going to be the average of the velocities times the time, right? So average of V naught and V final times t, using trapezoid equation, using area of a trapezoid equation. So delta x then is going to be the average of the velocities times t. Okay? Cool bananas. This is equation 3. Now we can rearrange it if we wish, because delta x is final minus initial position. So if I replace delta x with x final minus x initial, and I move x naught to the other side, I get x final is equal to initial position plus 1/2 v naught plus v final times t. Cool? So, tremendously powerful equation. Lastly, I want you to figure out equation 4. All right, I'm going to give you a hint. The simplest equation here is equation 1, right? That's v equals v naught plus at, right? Take this one, solve for t. Okay, then plug this into which equation? Well, we want equation 4 to not have t in it. It's nice not having to know the time. So we can actually make an equation that doesn't have t in it. If you solve equation 1 for t and plug that into equation 3, you will have it. With a little bit of algebra, and you would want to solve for v final squared. That's all I'm going to say. All right? So your homework is to figure out equation 4, and then after you do that, you could go to your website, go to constant acceleration motion link, scroll down to the bottom, go ahead and download worksheet 3. Okay, and on Tuesday, this is my guess, I imagine we'll whiteboard these. But feel free to get as far as you can, since you got a 3-day weekend. It only helps. And yeah, man, have a good one. Thanks for watching.